Hello my dear students, welcome to Teacher at Home. Today class we are going to learn the 12th chapter, Some Natural Phenomena. In this chapter, we shall discuss two destructive natural phenomena. These are lightning and earthquakes. We shall also discuss what steps we can take to minimize destruction caused by this phenomena. Lightning. You might have seen sparks on the electric pole when wires become loose. This phenomenon is quite common when wind is blowing and shaking the wires. You might also have seen sparks when a plug is loose in its socket. Lightning is also an electric spark, but on a huge scale. Ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that the wrath of gods was visiting them. Now, of course, we understand the lightning is caused by the accumulation of charges in the clouds. We need not be afraid of lightning, but we have to take precautions to protect ourselves from the deadly sparks. The sparks that the Greeks knew about, the ancient Greeks knew as early as 600 BC, that when amber is a kind of resin, was rubbed with fur, it attracted light objects such as hair. You might have seen that when you take off woolen or polyester clothes, your hair stands on end. If you take off these clothes in the dark, you even see a spark and hear a crackling sound. In 1752, Benjamin Franklin, an American scientist, showed that lighting and the spark from your clothes are essentially the same phenomena. However, it took 2000 years for these realizations to occur. I wonder why they took so many years to realize the similarity. Scientific discoveries are a result of hard work by many people, can sometimes take a long time. We shall now study some properties of electric charges. We shall also see how they are related to the lightning in the sky. Let us perform some activities to understand the nature of electric charges. But recall first what you might have played as a game. When you rub a plastic scale on your dry hair, the scale can attract very small pieces of paper. Charging by rubbing. Take a used ballpen refill and rub it vigorously with a piece of polythene. Bring it close to a small piece of paper. Take care not to touch the rubbed end of the refill with your hand or with a metallic object. Repeat the activity with small pieces of dry leaf, husk, and mustard seeds. Record your observations. When a plastic refill is rubbed with a polythene, it requires small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it requires a small charge. These objects are called charge objects. In the process of charging, the refill and the plastic comb, polythene and hair also get charged. Let's try to charge some other objects that are familiar to you. Type of charges and their interaction. We select some objects from the table for the next activity. Inflate two balloons. Hang them in such a way that they do not touch each other. Rub both the balloons with a woolen cloth and release them. What do you observe? Now let us repeat this activity with the used pen refills. Rub one refill with polythene. Place it carefully in a glass tumbler using the tumbler as a stand. Rub the other refill also with polythene. Bring it close to the charged refill. Be careful not to touch the charge end with your hand. Is there any effect on the refill in the tumbler? Do that to attract each other or repel each other. In this activity, we have brought close together the charge objects that were made of the same material. What happens if two charge objects made of different materials are brought close to each other? Rub a refill and place it gently in a glass tumbler as before. Bring an inflated charged balloon near the refill and observe. Let's summarize observations. Charged balloon repel a charged balloon. A charged refill repel a charged refill. But a charged balloon attracted a charged refill. Does it indicate that the charge on the balloon is of a different kind from the charge on the refill? Can we say that there are two kinds of charges? Can we also say that the charge of the same kind repel each other, while charges of different kind attract each other? It is a convention to call the charge acquired by a glass rod when it is rubbed with a silk as positive. Other kind of charge is said to be negative. It is observed that When a charged glass rod it is brought near a charged plastic straw, rubbed with polythene, there is attraction between the two. What do you think would be the kind of charge on the plastic straw? Your guess that the plastic straw would carry a negative charge is correct. Electrical charges generated by the rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. You have been reading about electric current since class 6. The current in a circuit, when makes a bulb glow, or the current that makes a wire hot, is nothing but a motion of charges. Transfer of charge. Take an empty jam bottle. Take a piece of cardboard slightly bigger in the size than the mouth of the bottle. Pierce a hole in it so the metal paper clip can be inserted. Open out the paper clip. Cut two strips of aluminum foil about 4 cm 1 cm each. Hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paper clip. Observe what happens. Is there any effect on the foil strips? Do they repel each other or attract each other? Now touch other charge bodies with the end of the paper clip. Do foil strips behave in the same way in all the cases? Can this apparatus be used to detect whether a body is charged or not? Can you explain why the foil strips repel each other? Aluminium foil strips receive the same charge from the charge refill through the paper clip. Remember, the metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying a charge or not. This device is known as electroscope. Thus, we find that electrical charge can be transferred from a charged object to another through a metal conductor. Touch the end of the paper clip gently with hand and you will find a change in the foil strips. They come back to the original state. Repeat charging of foil strips and touching the paper clip. Every time you will find the foil strips collapse as soon as you touch the paper clip with hand. Why does it happen? The reason is that foil strips lose charge to the earth through your body. We say the foil strips are discharged. The process of transferring a charge from a charged object to the earth is called earthing. Earthing is provided in buildings due to protect us from electrical shocks due to any leakage of electric current. Story of lightning. It is now possible to explain lightning in terms of charges produced by rubbing. During the development of a thunderstorm, air current moves upward while the water droplets move downward. These vigorous movements cause separation of charges by a process not yet completely understood. The positive charge collect near the upper edge of the clouds, the negative charge accumulate near the lower edge. There is accumulation of positive charge near the ground also. When the magnitude of the accumulated charge becomes very large, air, which is normally a poor conductor of electricity, is no longer able to resist their flow. Negative and positive charges meet, producing streaks of bright light and sound. We see streaks as lightning. This process is called electric discharge. The process of electric discharge can occur between two or more clouds or between clouds and the earth. Today we need not get frightened by lightning like ancestors did. Now we understand the basic phenomena. Scientists are trying hard to improve this understanding. However, lightning's strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. Lightning safety. During lightning and thunderstorm, no open place is safe. Hearing thunder is an allowed to rush to a safer place. After hearing the last thunder, wait for some time before coming out to a safe place. Finding a safe place. A house or a building is a safe place. If you are traveling by car or by bus, you are safe inside with windows and doors of the vehicle shut. Do's and don'ts during a thunderstorm. Outside. Open vehicles like motorbikes, tractors, construction machinery, open cars and are not safe. Open fields, tall trees, shelters in parks, elevator places do not protect us from lightning strikes. Carrying an umbrella is not at all a good idea during thunderstorms. If in a forest, take shelter under shorter trees. If no shelter is available and you are in an open field, stay far away from all trees. Stay away from poles or other metal objects. Do not lie on the ground. Instead, squat low on the ground. Place your hands on the knees and with your hand between the hands. This position will make you the smallest target to be struck. Lightning the house. Lightning can strike telephone cords, electrical wires, and metal pipes. During a thunderstorm, contact with this should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Bathing should be avoided during thunderstorm to avoid contact with running water. Electrical appliances like computers, TVs, etc. should be unplugged. Electrical light can remain on. They do not cause any harm. Lightning conductors. Lightning conductor is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept out in the air, and the other it is buried deep in the ground. The rod provides easy route for the transfer of electric charge to the ground. The metal columns used during construction, electrical wires, and water pipes in the buildings also protect us to an extent, but do not touch them during a thunderstorm. Earthquake. You just learned about the thunderstorm and lightning. This natural phenomena can cause large scale destruction of human life and property. Fortunately, this phenomena can be predicted to some extent. The weather department can warn about a thunderstorm developing in some area. If a thunderstorm occurs, there is always a possibility of lightning and cyclones in accompanying it. So we get time to take measures to protect ourselves from the damage caused by this phenomenon. There is, however, a natural phenomenon which we are not yet able to predict accurately. It is an earthquake. It can cause damage to human life and property on a huge scale. A major earthquake occurred in India on 8 October 2005 in Uri and Tangdar towns of North Kashmir. Before that, a major earthquake occurred on 26 January 2001 in Bhuj district of Gujarat. Ask your parents about the huge damage of life and property caused by the earthquakes. Collect a picture showing the damage caused by the earthquake from newspaper, magazines of those days. Prepare a short report on the suffering of the people during and after the earthquakes. What is an earthquake? What happens when it occurs? What can we do to minimize its effect? These are some of the questions which we shall discuss below. What is an earthquake? An earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. It is caused by the disturbance deep inside the earth's crust. Earthquakes occur all the time, all over the earth. They are not even noticed. Major earthquakes are much less frequent. They can cause immense damage to buildings, bridges, dams, and people. There can be great loss of life and property. Earthquakes can cause floods, landslides, and tsunamis. A major tsunami occurred in the Indian Ocean on 26 December 2004. All the coastal areas around the ocean suffered huge losses. Take an outline map of the world. Locate the eastern coast and Andaman and Nicobar Islands in India. Mark other countries around the Indian Ocean which could have suffered damage. Collect accounts of the devastation caused by the tsunami in India from your parents or other elders in the family or in the neighborhood. My grandmother told me that the earth is balanced on the horn of a bull, and when the bull shifted to other horn, earthquake take place. How could it be true? In ancient times, people did not know the true cause of earthquake. The ideas were therefore expressed in mythical stories such as the one told by Bujo's grandmother. Similar myths were prevalent in other parts of the world. Now we know that the tremors are caused by the disturbance deep down inside the uppermost layer of the earth called the crust. Crust, mantle, outer core, inner core. The outermost layer of the earth is not in one piece, it is fragmented. Each fragment is a plate. These plates are in continual motion when they brush past one another, or a plate goes under another due to collision. They cause disturbances in the Earth's crust. It is these disturbances that show up the earthquakes on the surface of the Earth. Colliding, brushing past. Although we know for sure what causes an earthquake, it is not yet possible to predict when and where the next earthquake might occur. Tremors on the Earth can also be caused when a volcano erupts, or a meteor hits on the Earth, or an underground nuclear explosion is carried out. However, most earthquakes are caused by the movement of Earth plate. Since earthquakes are caused by the movement of plates, the boundaries of the plates are the weak zones where earthquakes are more likely to occur. The weak zones are also known as seismic or fault zones. In India, the areas most threatened are Kashmir, western and central Himalayas, the whole of northeast, Rann of Kutch, Rajasthan and the Indo-Gangetic Plain. Some areas of South India also fall in the danger zone. The power of an earthquake is expressed in terms of magnitude on a scale called the Richter scale. Really destructive earthquakes have magnitude higher than 7 on the Richter scale. Both Bhuj and Kashmir earthquakes have magnitude greater than 7.5. The tremors produced waves on the surface of the earth. They are called seismic waves. These waves are recorded by an instrument called the seismograph. The instrument is simply a vibrating rod or a pendulum which starts vibrating when tremors occur. A pen is attached to the vibrating system. The pen records the seismic waves on the paper which moves under it. By studying these waves, scientists can construct a complete map on the earthquake. This can also estimate its power to cause destruction. Focus at surface epicenter seismic waves. Like many other scales in science, decimal is an example. Richter scale is not linear. This means that an earthquake of magnitude 6 does not have 1.5 times the destructive energy of an earthquake of magnitude 4. In fact, an increase of 2 in magnitude means 1000 times more destructive energy. Therefore, an earthquake of magnitude 6 has 1000 times more destructive energy than an earthquake of magnitude 4. Protection against earthquake. We know from the earlier pages that earthquake cannot be predicted. We also have seen that they can be highly destructive. It is therefore important that we take necessary precautions to protect ourselves all the time. People living in seismic zones where the earthquakes are more likely to occur have to be specifically prepared. First of all, the buildings in these zones should be so designed that they can withstand major tremors. Modern buildings technology can make it possible. It is advisable to make the structure simple so that it is quake shake up. Consult qualified architect and structural engineers. In highly seismic area, the use of mud and timber is better than using a heavy construction material. Keep roofs as light as possible. In case the structure falls, the damage will not be heavy. It is better if the cupboards and shelves are fixed to the walls so that they do not fall easily. Be careful when you hang wall clocks, photo frames, water heater, etc., so that in the event of an earthquake, they do not fall on people. Since some buildings may catch fire due to earthquake, it is necessary that all buildings, especially tall buildings, have fighting equipment in working order. The Central Building Research Institute Roorkee has developed know-how to make quick resistant houses. In the event that an earthquake does strike, take the following step to protect yourselves. If you are at home, take shelter under a table and stay there till the shaking stops. Stay away from tall and heavy objects that may fall on you. If you are in bed, do not get up, protect your head with a pillow. If you are outdoor, find a clear spot away from the building trees and overhead power lines. Drop to the ground. If you are in a car or a bus, do not come out. Ask the driver to drive slowly to a clear spot. Do not come out in a tremor stopper. Words, thrust, discharge, at plates, earthquake, electroscope, lightning conductor, negative charge, positive charge, Richter scale, seismograph, thunder, thunderstorm, transfer of charge, tsunami, and tremor. Some objects can be charged by running with or rubbing with other objects. There are two kinds of charges, positive and negative charge. Like charge repel and unlike charge attract each other. Electric Charges produced by rubbing are called static charges. When charges move, they constitute an electric current. Electroscope may be used to detect whether a body is charged or not. Process of transfer of charge from a charged object to the earth it is called earthing. Process of electric discharge between clouds and the earth or between different clouds causes lightning. Lightning strike could destroy life and property. Lightning conductors can protect buildings from the effects of lightning. An earthquake is a sudden shaking or trembling of the earth. Earthquake is caused by a disturbance deep inside the earth's crust. It is not possible to predict the occurrence of an earthquake. Earthquakes tend to occur at the boundaries of Earth's plates. These boundaries are known as fault zone. Destructive energy of an earthquake is measured on Richter scale. Earthquake measuring 7 or more on Richter scale can cause several damage to life and property. We should take necessary precaution to protect ourselves from earthquake. So that's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.